Okay, so this is our advanced topic session. Apologies, we're running a little bit behind, about a half hour behind so far, but that's not too bad. Chris Waldrop is going to talk about his adventures in sketching the night sky. So I'll turn it over to you, Chris.
Thank you. All right, can everyone see that? Hey, Eric, am I up?
Yeah, I can see it.
Okay,
yep.
Perfect. All right, so my name's Chris Waldrop. I've been in the club since about 2018. I work in Huntsville at the research park, but I live up between, in Tennessee, in between Winchester and South Pittsburgh up on Mont Eagle Mountain. So I've been just a little bit about myself and my setup. I've been observing since about 1985. I had a fantastic 5th grade teacher that had it must have been an 8 or 10 inch Parkes reflector and set up in the classroom. And so I expressed some interest in it. And then he gave me a couple of astronomy magazines to read. They were from 1984, I remember that. So he said he got them and didn't need them anymore. So then Halley's Comet came the next year. And I decided that I was interested in it, wanted to get into astronomy. And I picked a telescope that I wanted that year for Christmas. I was in 6th grade. And I picked through the Sears catalog. So we went to Asheville Mall in North Carolina, where I'm from, and looked at the telescopes. But my mom said, well, before we buy anything, let's actually talk. I have a guy at work that I'm good friends with, and he's an amateur astronomer. Let me talk to him. Well, suffice to say, on Christmas morning, I was not unhappy because he said no to the Sears and yes to a Celestron CO60 orange Cometron refractor. It was a cheap mass-produced refractor, but it got me hooked. So that was my first scope. It was a 60 millimeter. Then the second telescope, and this telescope was the one that helped me learn about money. It was a Celestron Super Polaris C6, and I wanted it bad. So that was in the summer in between 8th and 9th grade. So that would have been about 87. Really wanted it bad, but it was $740. I didn't have $740, but my mom did. And she said, I'll tell you what, we're going to learn about money. She said, I'll buy you that telescope. And we got it from a place called Adorama in New York City. But you're going to learn about money. So that ended up lots of yard mowings and allowance and cleaning the garage and things like that paid for that telescope. So it did teach me about money. All right, so my third telescope is the one you see here, this 8-inch f5 home-built Dobsonian. So it was on that Super Polaris mount until about 2004, when I asked a manager at work, who was an amateur woodworker, if he would help me cut a few pieces of plywood. And a few pieces of plywood turned into 17 hours worth of work. And it's the Dobsonian mount you see in that picture. But I ground the mirror myself. I drove, at that time, 3 hours in between Asheville and Charlotte, North Carolina, twice a week for telescope making class. So I ground that one, and that was in between high school and college. That whole summer, did it in about 30 hours of actual grinding time. The current telescope is this one. I took this picture last weekend from my deck. Last Saturday, I set it up. It's a 15-inch reflector. So with this one, sketching, like I said, sketching got way more fun because you can see a lot more detail and a lot more objects. So it opened up the doors, and now I got it, like I said, about 2 years ago. So this is a fantastic telescope. One thing I will say, just like what Tom said this morning, he recommended people not get above a 12-inch. So the 15-inch, I can definitely handle it, but the problem with the 15 versus the 8 or the 6 is setup time. So I've got a 2-hour commute each way every day. So when I get home at 7:30 every night from Huntsville, I don't really want to take time to set up a scope. I want to grab a scope and take it outside. So this one, and especially now since it's dark when I get home, this needs to be set up in the light. You need to take time because you have to collimate it in between every setup time because it's a truss tube design. It's not a rigid tube, it's got the poles. So you have to collimate it every time. And also it takes a while for that 15-inch glass to cool down. So if it's not in my notebook, I didn't see it. I sketch everything I observe. I've been sketching a long time, and this is just my way of keeping track of what I see. It's a way of connecting with the universe. I have, not that I have anything against astrophotography. I got a bunch of good friends that do astrophotography, but I have no software. I have no cables. I have no computer to keep up with. I do high tech all day, working in aerospace. And this is my way to kind of relax in the evenings. So I have my dew heater, my phone that I play music on, and my flashlight. That's my electronics. So photons go straight from my eye, from the object to my eye, and I get to tease out all the details of all the deep sky objects I see. And it's a beautiful journey. I see a lot of my way there. Pick an object that I want to see and find it. And a lot of times I'll find another object on the way and I'll stop and sketch that. So, I don't even have finders on my telescopes. I just use the Telrad to find the general vicinity of where I want to go, the brightest star nearby I find. And I star hop through the telescope using usually a 32 millimeter eyepiece or a 40 millimeter eyepiece. I star hop through the scope at low power and match what I see to the Uranometria 2000 chart. And usually I can find an object within 5 minutes or so doing that.
Hey, Chris, we got a request. Can you put your slides into slideshow mode so we can see it bigger on the screen?
Sure.
Down in the lower, what's that, right corner? That little projector looking. Now the next couple over.
How's that?
There you go. Perfect.
Hey, do you want me to go back to the beginning and just go through each one for a few seconds?
No.
Okay. So my favorite objects are everything in the sky. So particularly globular clusters and planetary nebulae. Those are my two favorites. My goal is to observe every NGC object. Not quite there. I've observed probably about almost 1,000, but not every one. So here is my first attempt. Please do not make fun. This was with my 6-inch back in 1988 from my home just outside Asheville. I did start sketching. Actually, I'm sorry. My first attempt was in 1985, and I did a lot of observing with the Cometron, the 60 millimeter refractor. And but I did it on loose leaf paper, mainly of Jupiter, and I ended up losing those over time. So in about 1988, there's an article in Astronomy magazine that said how you should really do your records. And what you're seeing to the right is copied from that article in Astronomy. So this is the first sketching attempt that I still have a copy of. So this was M13 with my 6-inch Celestron SPC6. So the completed observing projects. I've seen and sketched all the Messiers. Then I went back with my 15 by 80 binoculars and did it again with binocular Messier. Did the Astronomical League Comet. I've seen all the globular clusters visible in an 8-inch scope from our latitude, including Mayall 1, the globular in M31. I did the Saguaro Astronomical Club 100, and I'm also almost done with the Herschel 400. I've got about 50 left. And when Don talked a minute ago about things taking a few years, as of 2002, I'd seen 88. So I keep track of a running list of how many I have left. So, and I don't know what I'll do after that. Maybe I'll do the Herschel 2s. So it's very easy, very low tech. Like I say, a scope and a dew zapper and a flashlight. One thing I did want to mention, let me go back to this drawing. One thing, after 30-some years, if you'll notice the dark circle around the field of view, I used a Sharpie for that. And I have experience now, do not do that. Because chromatography with just the moisture in the air has now, if you look with a bright light, has caused that black from that Sharpie to separate into different colors. So I use archival Pigma pins now. I'll talk about those in a minute, but don't use Sharpies. So what I use now, the Micron pins, they are, here's an example of one. There's a picture where you can actually see one here. They come in different thicknesses. So I usually use the 005s and the 01s for the stars, and then the 08s, the fatter one, is what I use for making my field of view circle. I also use archival quality sketchbooks like this. They're made by Strathmore, and different size books for my binocular and solar system objects. For those, I use the smaller one. And then for my deep sky, I use the larger one. My toolkit, I have erasers. I have blending sticks. One thing I've started using recently, I've gone through different types of pencils, including the normal pencils like you'd use. I tried these from Lowe's and Home Depot. The nice part about the flat ones is they won't roll off your observing notebook. But one type I've recently found is these, and this is pretty much, it's Create a Color. And what it is actually a graphite stick with a plastic coating. So that way, if you use a normal graphite stick, you get smudges all over your fingers just from the graphite didn't get on your notebook. This is a coated pencil, and I really like these. They come in different hardnesses, I must have the others in my, right here. And I cannot recommend these more highly. You see, the blending sticks that I talked about a minute ago, I'll talk about those. What you do is when you're drawing, you use these instead of using your fingers. I've heard people talk about using nose grease, where they'll take their finger and kind of do this and get a little bit of the grease. But like I said, I use archival quality books, kind of like to keep everything clean. So this is a Tortillon, I think is what they call it. It's rolled up paper. And once you do once you lay down your bed of graphite, you can use this to kind of smudge it and get the nebulosity that you're interested in. Sources of supplies. So a lot of Amazon, Michael's. I haven't found any art supply shops in Huntsville. There's a place in Low Mill that I found recently, but it was just a little tiny room. They had a few art supplies. I usually go to either Plaza Art or Jerry's Artorama in Nashville, since I'm about 2 hours north of Huntsville. But you can order from the internet as well. Never leave home without this. That is the circle template. I had a situation where I drove back in Raleigh, where lived for most of my life. I had drove the 30 miles out to the observing site, pulled out my sketchbook, and I had not made the circles for the upcoming observing session. So what I usually do now is go ahead and add some circles like this to my notebook. So when I get ready to observe, they're there. Well, I hadn't done that. Luckily, somebody had a Coke can that hadn't been opened, and I flipped the Coke can upside down and used that as my circle template. But never leave home without that, just in case you're not prepared. They have the kneaded eraser, like you see in the picture. Here's an example of one. What you can do with a kneaded eraser is you can take it and kind of wad it up and pull off little sections like this. So it's different than a normal eraser like you might be used to, something like this. You can take it, and if I'm doing nebulosity and I want to be able to just erase a little bit, I can pull it off, roll it up into a little tube or ball, and use this to erase for the details. You don't have to be an artist. I promise I'm not one. But I do try to represent what I see through the eyepiece. You focus on the larger stars, especially in open clusters. You'd spend hours trying to get every little tiny star in some of these open clusters. Then I add the smaller stars to anchor the subject. Viewing tools in my notebook. I'll show you an example of one from last Saturday set up here on the deck. You got the Bubble Nebula. So that's an example of what one of my notebooks looks like. So I have the viewing tools, the power, the eyepiece, telescope location, the subject of what I'm drawing, with the type, magnitude, and size, the location in the sky, RA, deck, constellation, sky conditions, and a source reference. Like here, it was in Uranometria chart number 58. So that way I can go back later. And another thing I do is I have the Uranometria field guide. So I get all the data for the object from that field guide. Here's some examples of some observing forms. The ones I started out with are the ones that I made from the article on astronomy. And then there's a magazine back in the late 80s, early 90s called Observer's Guide. I got all those. And you could buy an object or buy an observing form from them. I used that for a while until I started my freshman year at NC State, and I went to the student bookstore, and that's when I learned about these hardback notebooks. They're fantastic. So the black hardback Strathmore artist notebooks, definitely make the observing forms in advance. So you position the object in the center of the field with your telescope. I use a soft pencil and lay down a bed of graphite, no matter what it is, if it's nebulosity, globular cluster, galaxy, to represent the orientation and position. And then I can always erase to make it match what the object actually looks like. Obviously, a star cluster would have to be different. Another thing I do not do, I do all my drawing at the eyepiece. I know some people kind of rough it out and then they'll get up the next day and they'll go back and finish it. I don't, because there's too many chances of you forgetting what you saw or missing something or misremembering something. I do all my sketching at the eyepiece. Use the pigment pens to position the stars. Obviously, the finer the tip, the dimmer the star. But as a star chain or pattern, I might go ahead and add that. Use the blending stick to shape the main object and have the shading represent the general appearance of the object. The moldable erasers, that's what I talked about a minute ago, create voids and dark lanes, especially dark lanes in galaxies, as well as cleaning up. And it is just like bubblegum. Then if you'll notice when I'm done, I mark the orientation of the object I sketched with a W. You might be able to see here for west, so I know the direction. Try different forms. The ones you're seeing in this picture are from the Observer's Guide. Put it in a trapper keeper. Also, I don't recommend that because I found out that since it's vinyl, it gives off some type of gas, I guess, from the PVC, maybe hydrochloric acid or something. So I've moved it over to a different notebook. So do not do that. So here's an object I saw. Don told me when I gave this presentation last that no way you could see this in Carefree now because the housing developments have moved in. But I went out in '92 to visit a friend that had a 20-inch home-built telescope. And he let me observe from there. One thing you might notice in that, sometimes it happens is, especially there, since you're drawing the stars on top of the nebulosity, occasionally it'll smudge. And that's what happened there. If you notice, it looks like a line in the drawing. Here's a galaxy I observed, NGC 4565 in Coma Berenices from their Raleigh Astronomy Club observing site. Saw that, the Deer Lick Overlook, and that's what the Deer Lick Galaxy cluster was named after, this particular overlook. The Charlotte Club puts on a convention called Southern Star every year, and well, except for this year. And they have an observing site at one of the overlooks nearby. This is a open cluster I saw not too long ago. Cool comet. About the only thing I haven't figured out how to sketch yet are dark nebulae, since I draw with, so the dark is equivalent to being light. I guess I would have to fill in the whole field of view dark and then erase what I want for dark nebulae. So. Galaxy pair, and you notice I will go into the fine pen and annotate which galaxy is which to make it obvious, like in that one with Markarian's chain. This is a Planetary Nebula I saw back in 2017, and on this one I have the tick marks to show which one of these stars is actually the Planetary Nebula. So I usually will, you have especially with this one, it has the O3 filter. The O3 will kill all the stars, but leave the nebula. So you sketch it with the stars, and then you blink it with the filter. You take the filter, and you go back and forth in between the eyepiece and your eye to identify, especially with the stellar planetary, to identify which one is the star and which one is the nebula. Another open cluster, and like this, there were probably way many thousands of more stars visible, but I just got the brightest ones. The patterns, like that trapezoid there in the middle, stood out to me. Another open cluster. Another comet. I also have, if y'all can see, this was a most recent comet. With Neowise. I went out to Swanee to find that initially near where my wife works, and I found it with binoculars, and then a few nights later I came back out and sketched it with my scope. One thing that's not in the slides that I've started doing recently is some planets. doing some planets with some colored pencils with Mars the other night. So with the orange and red colored pencil, the one thing I found, the colored pencils don't erase as easily as the actual graphite does. This is Comet Holmes. That was that wonderful comet that went from something like magnitude 17 to magnitude 2 overnight. Occasionally do planets, not as much as I do deep skies, but planets, Jupiter. Now, how do I keep track of over 1,000 sketches? So I have two methods. I have a box of index cards. So each object that I observe gets a 4x5 index card of what it is with the NGC or M number, what constellation and common name, then what number it is in which notebook, where I observed it, where the date. So not only now do I have a record in my observing notebook, I have this card file, and that is one, and the cards stay home because if they were to ever fall out or me drop them, it'd be a mess. The second method I have is this guy. This is my backup system. This one actually goes out with me on every observing trip, and that's Tom Lorenzen's 1,000 plus Amateur Astronomers Field Guide. So that goes, and it also gives me objects, ideas of objects to observe. So in this one, the way I keep track is for my backup system, and yes, I'm probably OCD, is I write in the margins, I put a check by what I see, and then I write here on the side when I observed it and from where. That's an example, if that's easier to see. And also the people you'll meet. So I take all my observing notebooks to the different conventions and star parties, and I get people to sign it. Got Barbara Wilson at some of the Texas star parties, Sue French from Sky and Telescope, Robert Reeves, Carolyn Shoemaker, editor of Sky and Telescope, Jay Passachoff and Al Nagler signed at Southern Star a couple years ago. So enjoy, it's great, and they get to flip through my sketches and give me constructive criticism. And it's just a great way to keep track of what you get to observe. Inspiration for objects to observe. Astronomy and Sky and Telescope, Amateur Astronomy. If you guys don't get that, that's published by Charlie Warren up in Lebanon, Tennessee, just outside Nashville. It's a fantastic magazine, probably my favorite, very observing centric. The Webb Society in England, they have a fantastic magazine as well, and it's very affordable. The Astronomical League clubs, like Don was talking about. Then I have old issues of the Betelgeuse, the National Deep Sky Observer Society. They went defunct around 2000. Deep Sky Journal, and Observer's Guide. Those three are not published, but I do have copies of most of those back issues. So I can flip through those to get ideas of objects to observe. Any questions?
Hey, Chris, this is Corey. I was wondering, how do you see your books in the dark? Because I would think even under red, it would be really hard to see anything.
Yeah, it is. And at one of the Tennessee stargazes at Fall Creek Falls, Misty Ball had a flat magnifying lens. It's a dome shaped, about this big around, that has a curve in it. And that is fantastic for putting over uranometria, because now even with the dim of red light as I use, even the print in uranometry is really hard to read. That magnifying lens helps a lot. Plus, it's a good paperweight. But you want as dim a light as you can use to see and still draw and still see the object.
Yeah, definitely. Thank you.
No problem. Anybody else?
Yeah, Chris, I had a question. You're, as I understand it, you don't use any digital setting circles or anything, right? You just star hop these objects.
Yes, star hop through the scope. Yep.
That's an insane accomplishment for anybody who's tried to do that.
You know, if you tried it, you know, like I use with the 8-inch. You star hop at 32 power, and it's easy just to match up the field with what you're seeing. You kind of sometimes you're looking at uranometria, and you kind of have to turn the book sideways or something like that to get it to match the field of view. But you're just looking and as you look at the scope, and you kind of just you follow it that way, and it's incredibly easy to do. Like I said, I can easily find an object within sometimes 10 minutes if it's in Sagittarius or something where there's a lot of stars, but it's pretty easy.
Okay, well, let me just note that you said 5 to 10 minutes.
Yep.
The digital setting circles, it's like 5 to 10 seconds.
Exactly.
But anyway, I just want, if it's of any value to anybody, I just want people to know, here's my my notebook. I got a notebook. I'm inspired by all this stuff. I'm really doing it. I've got a couple of weeks ago, I went out and got pencils and all this other stuff. So I'm like sitting here scribbling down very serious notes here. I'm planning to go through your presentation again and take more notes. But this is really awesome stuff. This is really, you know, a lot of people don't understand that if you start doing astrophotography, you spend a lot of time wrestling with technology. And there's nothing wrong with that. I like doing that sometimes too. But there are times when I want to, you know, I use this to unwind. You know what I mean? You go out, it's dark, you're decompressing, and sketching seems to me like it's a lot better path to decompressing than more technology. But anyway.
Yeah, and another thing is that something like this, it might have taken me to do this whole drawing maybe half hour to do everything. You read some of the observing magazines, and it's like, well, I went out and saw 50 galaxies, this night. I don't see that many. I might see 5 or 6 objects in a night, only because I'm taking my time to observe them. And sketching really makes you take time to stop and observe what you see.
And how dark is your backyard? You're doing this all in your backyard, right?
Yeah, it's 6 to 6.5 magnitude. So
like Bortle 4, Bortle 3 or 4, something like that?
Yep. Milky Way's bright. Looks like clouds at night.
Okay.
Yep. I mean, I pay a price for that. I got a 2-hour drive to Huntsville every morning, but
Yeah.
It's like.
All right. Any other questions?
I have a question. Yeah, I did. I'm sorry.
Go ahead.
So
Sure.
do you feel, this is Corey, do you feel like you really get a chance to understand or not understand, but like to know these objects more when you're sketching them versus just what you may have done when you've observed something?
I think so. Yeah. And one thing I also don't do is I usually try not to read in Tom Lorenzen's book. He'll talk about, something like extremely bright, large, well-resolved, rich, compressed beauty, rivals M13. I try not to read those before I get my impression because I don't want to be biased as to what I'm supposed to see.
Cool.
We'll look at those when I'm done to make sure it matches. If I find something incredibly hard and he says brightest objects in the sky, then there's something wrong. But, but I have found that recently with the 15, it's a little tougher to observe. This last weekend, I had the Ring Nebula up at about 735 power, trying to look for the central star. Couldn't find it, but the amount of detail was incredible. And the 8-inch, you're like, yep, I saw it, and there's a ring, and it's got a hole in the center. But with this, I mean, there's details to the wall structure of the ring itself. It's pretty incredible.
Very nice. Okay, we're running about a half hour behind, so we better cut off questions there. Anybody else, you can still ask questions in the chat if Chris will remain on for a little while.
Thank you for letting me present.
Well, thank you very much. That was really cool. Like Don, I'll echo what he said. After I saw your talk probably about a year ago now at VBAS, I went out and bought some sketching stuff myself. I haven't had an opportunity to do a whole lot, but I've got my uranometria and one of those big glass domes, which is really helpful because there's a lot of detail in that star guide that, especially when you're outside at night, is very difficult to see. So I'll echo that. It's pretty fun to sit and actually take your time to enjoy an object versus trying to find, like you said, 50 galaxies in a night. All right, so our next talk is going to be by Fred Hermann on astrophotography.
Yeah, hello everybody. Can you hear me okay?
Yes.
Okay, I'll go ahead and share my screen here, okay? All right, so I assume everybody can see my desktop right now. Well, I'm Fred Hermann, And I've got an observatory in the backyard, Owl Mountain Observatory. And I had my images published like Astronomy magazine, Sky and Telescope, National Geographic, Discovery Channel, and so on and so forth. I've been doing this as an amateur photographer for, I guess, since the early 1990s or so. And those are some links to some Facebook page, as well as my own web page that hasn't really been maintained. So most current stuff would be on the Facebook page. Okay, this is me at Stonehenge, one of the earliest observatories, I guess. I guess it probably goes down, I don't know, 46,000 years ago, a little bit south of England. Kind of a neat place to go, out in the middle of nowhere when you first get there. I worked for about, well, actually, I worked 30 years at it, the North Alabama Space Agency, commonly known as NASA, Marshall Space Flight Center. I had a good time out there. Part of my time, which was this kind of like a part-time deal, where they basically called you up and say, hey, can you do a test on Tuesday and Thursday, doing astronaut training for, say, shuttle missions in the neutral buoyancy simulator, which is now a stop on the museum tour. So they basically shut that down, and all the neutral buoyancy type training is done in Houston. So I guess there's not much more diving done out there since it's no longer full of water. This is a picture of the observatory from the outside. A couple years back when we had some snow. This is the optics that I'm currently using, a 14-inch plane wave. I think you can see my cursor, right? Is that an affirmative?
Yes.
Okay.
Yes, we can.
All right. Okay, so anyway, this is the plane wave. Basically, my back doesn't like bending around telescope stuff. So basically, all my observing is pretty much automated. So I pretty much tell the observatory what to do, what objects to take, what exposures to take, when to take them, so on and so forth. And I just hit the go button, and it goes on out there and starts imaging for me, okay? The control computer is this little laptop over here. On the back end of the telescope, basically we have what I call a poor man's adaptive optic. Basically, it's a piece of plate glass mounted on two voice coils, if you would. So basically it just kind of flip-flops in the XY axis up to, does corrections up to around, I don't know, 7-8 times a second, depending on how bright my guide star is. Right behind that, this is all part of the camera assembly. Right behind that, you have the filter wheel. So basically the camera proper has a monochrome chip in it, CCD. It's about 36 millimeters. And of course, you've got to have a lot of counterweights because this is fairly heavy setup right here. It's a picture of myself again. Back in, you can see the camera here. Probably hardest part of doing this type of imaging is cable management, believe it or not. The fellow down here on the bottom is Jerry Fishman, a guy I used to work with out at Marshall. He won the Shaw Prize, which is sometimes referred to as the Asian Nobel Prize. This is shortly after he won his $1 million prize. So I guess he was coming over to maybe size up how he wanted to put his observatory together and spend his money. Okay, this is basically what a raw image looks like straight off the telescope. So that's one raw image. And basically you can see some like vertical banding and stuff like that. A lot of noise. This is about a 700-second exposure using a hydrogen alpha narrowband filter. Does great work for getting rid of light pollution. I'm in Southeast Huntsville, so basically we have relatively bright skies, especially when you look towards the north, since I'm in the south part of the town. And there are chip defects too, like this one line right here. But that's all basically taken out with calibration frames. And this is a snapshot of the laptop. So basically, you've got your camera control software, you got your focusing software, and this is basically my horizon area within this little circle right here where you can see the stars. And then you have the executive program, which basically tells the computer what to do and when to do it. Okay, this is taken from base of Montesano. We're going up to do, I think, the Pan-STARRS comet that night. Do a little bit of everything, I guess. Little hydrogen alpha, solar observations, see some of the prominences. I actually did a presentation yesterday to a class of 5th graders in Albuquerque, New Mexico yesterday. It's one of the pictures I showed them, along with the solar prominence and the Earth, just kind of give them an idea as to you know, how things are relative in size to each other. While I'm doing that, let me show you some things here, which basically illustrate the fact that things aren't always necessarily static when it comes to the universe. This is that same picture, basically a short animation. I think it's maybe done like over a course of an hour or so, where you can actually see, you know, the solar prominence in action, so to speak. These are basically just dust particles down here. They're moving kind of like from top to bottom. You can ignore those. And the easiest way to do, and the cheapest way probably to do astrophotography, is just get out your smartphone if you've got one that does, you know, exposures over time, and just point it up towards Polaris and have it take an exposure, say once every 30 seconds or so, and then go ahead and stack those images. I actually can't see Polaris from my observatory because it's behind these trees over here. So anyway, this is kind of a neat object in terms of how things move over time. What I did here is I took the very last image in the sequence, which is the largest. I think I took in 2011, according to the credits right here. And this is the M1 Crab Nebula. And I went back and found some images of the crab, I think going back to 1939, I believe was the date. So basically, this is the expansion of the Crab Nebula from about 1939 to 2011. I think it's over like 4 images. So basically, you just register the main stars in the background, and that sort of shows you how fast the crab is expanding. I'm sure most of you in the group probably understand the crab. It was a supernova about 1,000 years ago that exploded, and basically it was visible during the daytime. The Chinese recorded it, made observations, and arrows and all the other cultures at that time. So basically, I calculated that the material is moving, give or take, around 1/10 the speed of light. So basically, it tends to a lot of energy right there. It tends to move pretty quickly. Okay. Let's see. We were talking about comets earlier. Sometimes you can do some comets. If I see one that looks interesting, I'll go ahead and take a shot of it. This is a little GIF animation. Here's a Pan-STARRS short animation. Of course, everybody knows that the direction of the comet movement isn't necessarily in the direction of the tail, okay? Because obviously the tail is being pushed backwards by the solar winds. So the comet's actually physically moving this way, but the tail is going in the direction of the solar winds. So obviously the sun will be over here somewhere. Okay. Like everybody else, I took a short trip, I think it was to Pittsburgh, Tennessee, to be in totality. So I tried to recreate here in the GIF anim what it looked like along with the chromosphere and totality. I think we had about 2 minutes of totality, as I recall. So that was a really cool experience. First time I've ever seen an eclipse, and a total solar eclipse. Really neat. Enjoyed doing that. Okay, so now we'll go back here to the slideshow. And okay, so this is the last frame here showing the chromosphere of the total eclipse in 2017. One thing they say is the moon will make any telescope look good. Everything looks good in any telescope when it comes to the moon. Very bright. I do a little bit of planetary astrophotography, not a whole lot because it's a whole different method. Basically, you use a video camera, and then you have the software pick the sharpest images from the video, and then you start stacking those images into an object. There's Saturn. Here's a comparison from 2011, which was a different optic than I'm using now. Basically, of the pillars of creation. So on the left, you can see my version of the pillars. And of course, on the right is an image done by the Hubble Space Telescope back in 1995. So obviously, there are advantages to size because the Hubble uses a 100-inch telescope. I think the image on the left was using a 12-inch telescope, as memory recalls at that time. And also, I'm basically imaging from the bottom of a swamp as opposed to being out in space with no atmosphere. This is a not Alpha Centauri, but Toucan, a globular star cluster in the southern hemisphere. Really neat what you can see here in terms of detail. Lots and lots of stars, billions and billions of stars, as Carl Sagan might have said. Okay, as far as depth goes, I've picked up, actually been able to determine the shapes, in other words, of the galaxies, being able to determine whether or not they were like face-on, irregular galaxies or edge-on type galaxies from, say, almost a billion light years away. So this right here is the galaxy cluster, Coma Berenices. I hate pronouncing those words, so I usually get them wrong. But then the rectangle, if you go up, there's like a, this is from an astronomy program, and each of those little blue dots is actual galaxy, not a star. And then you go out here to an image done by the Spitzer Space Telescope, which gives you a little close-up view of the center of that star, of that galaxy cluster, rather. Okay. There's a lot of pretty stuff out there in the image. So right now, I'm not going to try to get into the details of every image, every image, but basically this is a dark emission type reflection nebula. I guess there's a little bit of everything in this guy. So basically, the cheapest way, if you want to get into at least the processing of astro images, to go to the Hubble Archive, Legacy Archive, and just download some of their data and start stacking them themselves. Especially useful if you want to do some really high resolution detail stuff, because this little guy right here using my equipment looks like a little blob, nowhere near the detail of the Hubble, of course. This is Thor's helmet. Here's the Helix Nebula, also referred to as the Eye God. You can see a little regular galaxy right here. Basically, this is a planetary nebula, and at its center is what is left of the star. So, of course, everybody knows that our star, our sun, will basically become a red giant and eventually become a planetary nebula, and it'll begin that process in about 4.5 billion years from now. So, hang on. Things are going to get kind of warm. Here's the Horsehead Flame Nebula. This is the Elephant's Trunk. Here's the Pelican Nebula along with the North American Nebula. These are all real popular bright objects that people like to do a lot. Here's another image of the Pelican. Here's the Jellyfish Nebula. Call that for obvious reasons. The Dolphin Nebula. This one is kind of a deep exposure. I probably spent about 24 hours or so actually collecting the data for this image. But what I do is I can go back from night to night, week to week, if I want to, depending on how deep I want to go and how dim the object is, by doing plate solves with the telescope. So I can go back and basically center the scope within anywhere from, say, 1 arc second to, say, 10 or 12 arc seconds. So I don't have a whole lot of waste when I go, back to objects from night to night in terms of having to crop and stuff like that. Here's another image of the crab done in color RGB. So basically what you end up doing is like I said, I have a monochrome chip, and then I rotate filters in front of the chip. Typically, this one would be a combination of RGB filters for the basic colors and the star colors. And then I'll use narrowband filters, primarily HA, hydrogen alpha, and O3 oxygen filters. This is a deep image of the Dumbbell Nebula. There's probably maybe up to 30 hours worth of exposures, because typically when you see an astrophotography image of the dumbbell, you normally only see the bright intersection. But when you start going deep and you start doing integrations, let's say, 24 to 36 hours worth of data, you can really start bringing out the dim stuff. Here's an example of what you would see using a hydrogen alpha filter versus a sulfur filter versus an O3 filter. Put all three of them together and you get, something like that, which again is the Dumbbell Nebula. Here's our neighboring sister galaxy, the Andromeda Galaxy. Everybody knows that it's going to basically run into the Milky Way in about, I don't know, 3-4 billion years now. Just about the same time that the sun goes or turns into a red giant. Here's a popular image of the image of the popular Orion Nebula, M42. Everybody's talking about the Messier catalog earlier. This is very close to M42. It's called the Running Man Nebula. Basically, he's got his arms out here, head and his body. The Pleiades, also known by the Japanese as the Subaru. And if anybody owns a Subaru car, you'll know that you have an emblem on the front that has stars, and that's where the Subaru automotive line got its name from, was this star cluster. Going back to sketching, okay? This is a sketch done by Lord Rosse, and I think, 1700s or so, something like that. I'm not sure exactly when he did it, but around that time frame. And this is the Whirlpool Galaxy, and this is an image of the Whirlpool Galaxy done through my observatory back. Okay. Here's a small galaxy cluster, Hamburger Galaxy, off to the side here on 56 or 65, 66. And you see 3628. I did that in 2015. Here's a dark reflection nebula. This is M82, also known as a cigar galaxy. I'm not sure exactly what it looks like, a cigar galaxy, but that's what they decided to call it when they gave it its popular name. But apparently a very energetic galaxy, because all this matter right here has basically been driven off by the hot core of the galaxy itself. There's another little face-on type galaxy off in the distance. This is the Sombrero Galaxy. You see the dust lane fairly well on this one. Star clusters are always nice to do. This is an open double star cluster in Perseus. It's fairly popular. Witchhead Nebula. This is the Statue of Liberty Nebula. It's a southern object. The other thing you can do too is you can rent time off of places like, I think, iTelescope, assuming they're still in business. So, if I were to try to image this from my location here in Huntsville, basically I'd have to look through the dirt. So obviously this wouldn't work. So I just rented a little bit of time. And this is a bright object, so actually it didn't take me very much time at all. Probably maybe 30 minutes or less, worth of exposures to image this, or come up with the data to do the image. Another image of the Hamburger Galaxy. This was an image of NGC 6883 that I think was published fairly recently in Astronomy magazine, August of 2020. This is kind of not a very popular object, and it's a very dim object, so it took a lot of time to collect. But basically, I believe it's a bow wave formed by an energetic Wolf-Rayet star, which is somewhere around here, and then basically this material is basically being pushed off, and you know, from the energy of Wolf-Rayet. This is the Veil Nebula. I think this particular part of the veil they call the Witch's Broom. Here's another part of the Veil Nebula. These were done with narrowband oxygen hydrogen alpha filters. Here's a dark hydrogen alpha reflection nebula. This is the Omega Centauri Nebula. This is probably the mother of all, excuse me, not nebula, globular cluster. This is probably the mother of all globular clusters right here. You can also do wide field stuff if you want to. Mosaics is what this has done. So basically, you get yourself a short focal length telescope, stick your camera on the back of it, and then basically paste everything together in, you know, something like Photoshop. Okay. So earlier I showed you a picture of Orion Nebula. So this is kind of what the Orion Nebula looks like in relationship to the Witch's Head. This is the Barnard's Loop. Okay, so basically you have this loop of material over here. Then you have the Horse's Head and the Flame Nebula. And then basically you have the main stars of Orion, Betelgeuse, Bellatrix, and so on and so forth. So basically, this kind of puts everything in perspective. And another use for this, these wide field images, is you can kind of like, you know, say, okay, you can find something. If you don't want to use like a star catalog or do an internet search, you can say, okay, well, this little area over here looks interesting. So let me just go back and revisit this area right here. So what you do is you do a plate solve using some of the internet resources and then find out exactly where the spot is. Okay, a planetary nebula. Okay, this is not the Owl's planetary nebula, but it looks very similar to the Owl Nebula M97. That's actually PK 238.34.1. That means anything to anybody. Here's another pretty image, a lot of neat detail. Okay, this is the Rosette Nebula, one of my favorites. You've got a Bok globule. These are all Bok globules right here. All these little brown things where gravity is basically pulled together, you know, gas and dust, and form these neat objects. But here's the leopard like hopping out toward the center of the Rosette. This is a really cool picture, I think. A lot of neat objects. This is actually from the southern sky too. Okay, I think this is the wizard right here. Flip him on his side. I think the wizard's head is kind of like in this area right here. This one was one of my favorites. Kind of looks like something that you'd see in Harry Potter. You kind of imagine like a castle coming out of the middle of nowhere. Kind of has sort of a wizardy type of look here. Here's what, you know, appears to be angels coming off to the left here. A bunch of different globules and dark nebula right here. Basically, emission nebulas fluoresce, if you would. The hydrogen and oxygen gas basically fluoresce from the energy of the bright stars. So what ends up happening is you get dust and gas. Gravity starts pulling it together, starts creating a star nursery, if you would, starts firing off new stars. And then the new stars basically emit radiation, which causes the remaining material to fluoresce, and then you can take images of it. This is one of the least popular images. I kind of call it the alien because that's kind of what it reminded me of. This is a really dim object. Probably took me around 12, 14 hours worth of exposure data in order to image this guy. Don't really see this very often. This one is the Tarantula Nebula. This is actually in our very close neighboring galaxy, the Large Magellanic Cloud, I believe. And quite a bit of activity going on in here. This may very well be a supernova that's already exploded right here. You can see like an open star cluster. Okay. Okay, this is actually a presentation of actually a short video of a presentation that I gave to not a presentation, but a interview with editor from National Geographic. I'll play that here in a second. Okay, and we'll kind of wrap it up with that. Let me play this. This runs for a couple of minutes, and then I'll go back and do a final plug on a few things some books I wrote.
Today we're going to try to break down a very big, very complex topic, one that quite literally spans the universe, astrophotography. I've been noticing Fred Hermann's images for a while now. He's one of our most active astrophotographers on your shot. I realized when it came to astrophotography, I knew very little about what I was looking at or how these images were made. So I called up Fred, who helped me to understand I'm not the only one sometimes overwhelmed by the size of our universe.
To me, the sizes, the distances, and the times, involved with astrophotography and, cosmology in general are just, to me, humanly incomprehensible.
These spaces and sizes are so big that by the time the light reaches Fred's telescope, these objects can be thousands of years old.
As an astronomer, you are a time traveler.
During his time at NASA, he became a diver and helped train astronauts in the Neutral Buoyancy Simulator. It's the largest indoor body of water in the world. This is a place where astronauts can simulate being without gravity. It helped them train for things like the repair of the Hubble telescope. He worked at NASA for about 30 years, and upon retiring, he built an observatory in his own backyard.
I used to call it the Robo-Dome, because it's basically a robot, if you would.
Now, Fred will be the first to tell you, looking through a telescope is not nearly the same as producing these deep space images. Our eyes simply cannot see the colors that astrophotography brings to life. There are two main reasons for this. The first is our eyes cannot process a large portion of the light spectrum to bring out the colors that are there. And the second reason is, well, our pupils are not 12 inches in diameter.
The pupil size determines how much or how many photons that your light can actually collect of a particular object, okay?
Yeah, how much light we're letting.
Exactly. And so what we end up doing is when we're using the telescope, we're basically effectively increasing our pupil size.
So how are these brilliant colors brought out? As Fred explained to me, each pixel on a color chip is divided into 4 parts, a red, a blue, and 2 green. Now, the problem here is there's very little green in astrophotography. So by shooting on a color chip, essentially half your card is attempting to record colors that aren't there. For this reason, Fred actually shoots with a monochrome chip.
A typical image will be an R, red, green, blue image, RGB image. And what you end up doing is you rotate, and this is all built into the camera, okay? You rotate the filters in front of the sensor. So after you've done your red, your green, and your blue exposures, those exposures are then combined into a color image analogous to the way that they made the old Technicolor movies, such as the Wizard of Oz movie.
Scientists who use the Hubble telescope are often mapping different colors to different gases, like sulfur, hydrogen, and oxygen, to better understand what these objects are actually made of. The way Fred uses RGB filters, he's bringing out the quote-unquote true colors of each object.
It's very easy to basically go overboard and over-process the image, and at that point, you begin to basically lose the organicness, I guess, if you would, of the image very quickly.
These nebulas and supernovas and other galaxies you're looking into, they're in the past, right? You're looking into the past.
Absolutely, yeah. What you have to consider is that the photons that you collected that night, or the photons I collected in, say, 2011 for that chip animation, those photons were actually emitted from the stars surrounding M1 and the emission nebula 5,000 years ago. So at the time that those photons actually left the molecular clouds or the stars within that image, okay, Moses was wandering around the Sinai Desert somewhere, okay, which is pretty incredible when you think about it, because I mean, you know, when you start thinking like, you know, biblical events like Moses and things like that, I mean, that to us is ancient history.
You've mentioned that you think this is an art you can never perfect, and there are clearly enough objects out there that you could do this every day for a million years and not finish. So what keeps you doing this every night? What's the ultimate goal?
I just enjoy the aesthetics for producing appealing aesthetic images. I basically, you know, like I say, sometimes I am interested in some of the science behind the objects, but for the most part, I just enjoy the beauty of the universe.
Wow. Well, this has been fascinating. And if you'd like to learn any more about the images you saw here today, please go on.
Okay, everybody still with me? I hope.
Yeah, I'm here. That was great, Fred.
Okay, I just want to do one final plug here. I wrote a couple of books a while back. This is, like I said, this is not very current, okay, because I haven't updated it in a while. But there are some useful resources here. Like I've got, I did my own little Messier marathon, something I did over the course of a few years. So if you want to, you know, use references, you know, go out and actually do visuals and, you know, things like that, you can use this as a reference if you would. My most recent images are on Facebook. So if you just type in Owl Mountain Observatory or just Google it, you'll basically, you know, some of my stuff will show up in various forms, different places. I've also written a few books. One is Astronomy for Everyone, where I basically tried to do as the title of the book says, Astronomy for Everyone. I basically tried to present the differences between different types of telescopes, you know, what you need to, say, do visual observations, astrophotography, so on and so forth. And then this is a little more advanced book. This is Astrophotography, Just the Facts. There's a lot of information about astrophotography out there, but they're usually very large books that go into a lot of detail. I basically just wanted to keep it short. So this is, I think, 120 pages or so. And basically just the facts, more or less, just keep it to the point. I'm also a theist. So I'm one of those probably 50% of scientists that don't have a problem basically with religion per se, and also blending that, you know, the sciences of, say, the Big Bang and evolution and things like that. You know, basically blending those two together, because I feel that the more that you look at the details of the universe, the more, in my mind, it becomes evident that at one point or another there had to have been a creator. You know, of course, questions are, okay, who created the creator, things like that. I don't have answers to that. Don't have answers to everything, but I basically try to put it together in a form that at least I thought was reasonable in my own mind, if you would. So that's basically all that I have. I appreciate everybody staying around. I don't think there's going to be a whole lot of observing going on tonight, given the weather. And just want to say, finally, everyone have a wonderful 2020. I can't wait to New Year's Eve myself, but sometimes that's just the way it goes. So if anybody has any questions, I'll be happy to try to answer them.
Yeah, thanks, Fred. That was incredible. I think I was just amazed by your images, and I think I probably speak for everybody when I say I'm incredibly jealous of your observatory and your equipment. Looks like we did have one question from Tim Weaver on what make and model is your camera?
Yeah. Well, I've got different cameras. That particular one that you saw in the image is a S-Big 11,000. I basically started off with an observation deck. And let me see, I'll show you a picture of my backyard, okay? Hang on a second here. I live on the top of Blue Mountain in a fairly wooded area. And in order to get a halfway decent horizon, okay, especially like to the south, I had to build a 13-foot tall pier out of concrete using sonotube and reinforced concrete, things like that. And so basically this is what the base of the observatory looks like. So when I first started off the observation deck, I basically built this, 13-foot column concrete first, which then basically served as the base for, the pier for the mount. And then my wife wanted a sunroom, so I kind of made a deal with her. I said, okay, well, if we build the sunroom, let's just rip down my observation deck and let me put up a proper base for an observatory, because this observatory right here is made out of a type of plastic, which is very durable, but it's also pretty heavy. But nice thing is, if you're getting serious about astrophotography, is one thing you will get tired of very quickly is basically moving your telescope in and out. And also each time you do that, you've got to realign the telescope, so on and so forth. So once you have a fixed observatory like this, it's just basically a matter of, deciding what you want to image and then turn on the scope, drag your information over the network to the telescope and hit the go button, and then collect your images either when you go to bed or the next morning. So that's basically what it looks like. But I didn't do everything at once. I kind of, like I said, started off fairly small. And then as time went on, just like everything else, when you have a hobby that you really enjoy, like I do astrophotography, you tend to build on it.
That's
Any
cool.
other questions?
Corey asks, what stacking software would you recommend for a newbie, deep sky, not planetary?
Well, actually, for a newbie, what I would basically do is Google is your friend, as I always like to say. I'm sure you can find some free stacking software out there. Right offhand, I don't know the names of any, because I've been basically using, oh darn, my mind just went blank. CCD soft or CCD stack. That's some software that is paid for software. I think I used that for a long time. And right now, darn it, what the heck is the name of the software I'm currently using? It's, oh heck, my mind just went blank. I haven't really processed any images in a couple of weeks now. But basically, I would just do a search for like free sky stacking software, and I'd go from there.
Don Reed is asking what capture software you use, and do you use PixInsight for?
PixInsight, exactly. That's what I'm currently using. Okay, is PixInsight, and actually the book that I wrote is basically using PixInsight, and for some reason, I don't know why, I think my guess is it's the registration algorithms that they use in PixInsight, okay? But when you process images using PixInsight, the images tend to have a lot better pop, a lot better resolution than the registration and results that you get using, say, CCD Stack or some of the other free software out there. So what I'll end up doing is I do like batch processing. They've got some scripts in there, so you can basically do all your batch processing in a matter of seconds. Of course, you can also do that with CCD Stack, but PixInsight gives you a much better result. Yeah, I'm glad he mentioned PixInsight. Like for some reason, I just had a mental block there, couldn't remember it. But yeah, use that. And I get to a certain point to where I just, out of habit, some people say that you can get the same results using just PixInsight, but I prefer basically, doing batch processing and then certain processing within PixInsight. And then I get to a point to where I create like what I call my Luma object, which is the detailed information. Then I have my RGB information. So what I do then is I'll create 2 TIFF files, TIF, and then I'll basically go with Photoshop and do the color combination in Photoshop. And depending on what the object is, I might jump back into PixInsight and do a little more processing with that. So it's just sometimes it's a little bit of back and forth. But primarily PixInsight and Photoshop are the 2 softwares that I use right now. Any other questions?
Any other questions for Fred?
Yeah, did we get to the image capture? How does he automate the imaging runs? Does he use something like Sequence Generator Pro, or does he use a different software suite?
Yeah, that is one of the softwares that you can use. And as I recall, Sequencer Pro, I believe, you got to pay for it, right? Is that correct?
Yeah, I have a license for it. That's what I use, but I didn't know if that's what you used.
No, I'm not using that. I'm using something called Ccdo Autopilot. Okay.
Okay, I've heard of it. Yeah.
This is Autopilot right here. I've had this for years, and basically, John Smith is the guy that wrote this, and he upgrades it from time to time. And he finally went to a yearly licensing thing, and that's basically at the point where I quit upgrading, because it basically pretty much works fine. The version that I have, which let's see, is like 5.113. So that goes back to like actually, 2019. Huh. I don't remember him upgrading it back then. Maybe I got to upgrade that I don't know about. But I actually wrote my own executive software, which I was going to publish, and it finally got to the point. You finally get when you're writing your own software like this, something like Ccdo Autopilot. It gets to the point where you have to spend all your time testing the software. Like when you're doing plate solves and you're doing like, you do say a plate solve using the Naval Observatory. It's a 6 gigabit, star database. Then you have to do your corrections and, rotational corrections and things like that. But anyway, bottom line is I had to make a choice. Am I going to want to basically continue to develop the software to the point where I can sell it? And then when I sell it, basically it's a very limited audience that you're selling to. So I guess what you call a vertical software market. So you gotta charge a lot of money to make any money. Then you got to provide the support, and then you got to say, okay, would I rather get into the development of this software, which includes a lot of testing, which in case if you do that, then basically you don't have any time for imaging anymore. Okay, so it got to the point where I was basically, I'd gotten the plate solves and everything down right and gotten the outline of the software done, so it was actually working. And I finally said, well, no, this really just isn't worth it. So I basically discontinued, my development of the software. So it was fun while it lasted, but I just decided to discontinue the development of that software. Anything else?
All right, one last question. Someone asked about what you described as your poor man's autocorrect.
Adaptive
optics.
AO.
Yes. How does that work? Is that an item you purchased or built yourself, or what?
Yeah. Well, let's just go back to the high-end adaptive optics that like you see at professional observatories. I guess like what the Gemini telescopes and some of those other ones, I believe, use adaptive optics in order to get high resolution images. Okay, so what those guys do, the big boys, okay, and those systems cost, I'm sure, millions of dollars, is they basically have actuator solenoids on the back of the primary mirror. And I'm not sure, possibly anywhere from hundreds to thousands of those actuators on the primary. And what they do is they shine a high-powered laser, create their own artificial star, and based on the turbulence that they see based on their artificial star using the laser, okay, they then start actuating those solenoids on the back of the primary mirror, and they deform the primary to basically offset, you know, the distortion caused by the atmosphere. Now the problem is you actually have to get to the point where you got to start predicting, you know, what the disturbance is going to look like based on current observation, because by the time you observe the disturbance, it's already happened, see? So that's the big advantage to the Hubble, is the fact that it doesn't have to mess with any of that stuff. All it's got to do is basically keep 3 gyros spinning and no atmosphere, so no distortion per se. Now I use a poor man's version of that, which is purchased. Okay, it's also built by SBIG, Santa Barbara Instrument Group. They went out of business in California and sold their business off to a company up in Canada, and so they now sell their cameras from Canada. The guy that does repair work, I think he's still based out in Santa Barbara, California. But anyway, my little system basically is a piece of optical flat, okay, expensive piece of window pane, if you would, and it sits on some voice coils, okay, and I use a guide star, and you have to basically have a guide star when you're doing astrophotography. Otherwise, no matter how perfect your alignment is, you're always going to have drift. And even if you have perfect alignment, and the reason is because the diffraction angle basically changes depending on the amount of atmosphere that you're looking through. Okay, so basically your best images and the least amount of angular distortion that you're going to have is going to be looking at zenith straight up. And of course, as you look closer to the horizon, you know, it gets worse and worse. I think up to 30 arc seconds, I believe. So that's the difference in the angular distortion, say from zenith to the horizon, would be like 30 arc seconds, which is quite a bit actually. So because the field of view on the chip that I'm currently using, I think is around, here, I can look it up for you real quick here, give you exact information here as soon as the program loads. So if I go to view, field of view indicators, okay, so right now I'm using this XTXL STFCL 1000. This is the guide chip. And then if you look at the actual field of view, I think I got to go into edit. It'll actually, those are the number of pixels. So 4008 by 2745. It's around 45 arc minutes in width and somewhat less than that in the height. Okay, so that's my field of view right there. So this is kind of how I preview and set up my objects in this program right here. Any other questions?
Bernie, I think we probably need to cut off questions right there for now. We're running about 45, 50 minutes behind schedule, but our next session will be a little more freeform, I think, in terms of question and answer. So if you can, I don't know if you're able to stick around, Fred, for that. We might be able to have more discussion on astrophotography topics at that point. So thank you very much for everybody who presented on the advanced topics piece and the good questions that we had. I'm going to stop our recording of that session.